How does a four-stroke diesel engine work? A four-stroke diesel engine operates through a repetitive cycle of four strokes: intake, compression, power, and exhaust that efficiently convert diesel fuel into mechanical energy. Each stroke corresponds to a single movement of the piston, and the cycle requires 2 complete revolutions of the crankshaft. Here's a detailed breakdown of how it works. 1. Intake stroke. The cycle begins with the piston positioned at the top of the cylinder, top dead center. As the piston moves downward, toward bottom dead center, the intake valve opens, allowing fresh air to enter the cylinder. Unlike petrol engines, diesel engines do not mix fuel with air during this stroke, only air is drawn in. The downward movement of the piston creates a vacuum that facilitates the flow of air into the combustion chamber. Once the piston reaches the bottom, the intake valve closes, trapping the air inside for the next phase. 2. Compression stroke. During this stroke, the piston moves upward from the bottom dead center back to the top dead center. As the piston compresses the trapped air, the pressure and temperature inside the cylinder rise significantly. Diesel engines typically have a very high compression ratio, ranging from 14:1 to 25:1, much higher than petrol engines. This high compression causes the air temperature to exceed 500 degrees Celsius (932 degrees Fahrenheit), which is crucial for igniting the diesel fuel. Since there's no fuel present during compression, this stroke prepares the air for efficient combustion in the next stage. 3. Power stroke. At the end of the compression stroke, fuel is injected directly into the combustion chamber using a high-pressure fuel injector. The hot, compressed air instantly ignites the diesel fuel, initiating combustion. The resulting rapid expansion of gases exerts a tremendous force on the piston, pushing it downward. This stroke is where the engine generates power, converting the chemical energy of the fuel into mechanical energy. The force is transmitted from the piston to the connecting rod and then to the crankshaft, which translates the piston's linear motion into rotational energy. This rotational energy powers the vehicle's wheels and auxiliary systems. 4. Exhaust stroke. After the power stroke, the piston moves upward again. This time, the exhaust valve opens, and the upward motion of the piston pushes the spent gases out of the cylinder and into the exhaust system. This ensures that the cylinder is cleared of combustion byproducts, preparing it for the next intake stroke. Once the exhaust gases are expelled, the exhaust valve closes, and the cycle restarts. In summary, the four-stroke diesel engine's design emphasizes efficiency and durability. Its reliance on high compression and the absence of a spark plug distinguish it from petrol engines. Diesel engines are particularly efficient because they extract more energy from the fuel due to their higher compression ratios. This makes them ideal for applications requiring high torque and durability, such as in trucks, buses, and industrial machinery. However, their robust construction and precision-engineered components are necessary to handle the high pressures and temperatures involved, ensuring long-term reliability and performance.